Hello everyone, how are you all? I hope everything is fine and you guys are preparing well for your NEET exam. At this point of time, you need proper concentration for the NEET exam. Do not get yourself deviated because this is the high time only. Like last 1 month is remaining. So keep yourself on the right path, keep yourself focused. Okay, do not over stress yourself, do not think of here and there. Just put yourself completely into the studies. Hopefully, your efforts will be fruitful. Okay, so in this video we will discuss a lot of questions on current electricity. Current electricity is a very high weighted chapter for NEET exam. So we'll see what kind of trends of questions are there that they have been asking in current electricity. So through this question also, with the question also we'll try to revise some of the concepts. Okay, so before jumping into question, we'll see some of the concepts. So first concept itself is I equals to dq by dt. So this is called instantaneous current. So if charge is given as a function of time, charge is given as a function of time, you will differentiate the charge, you will get the value of instantaneous current. Okay. Second concept is average current. So they can ask you the average current, so you have to calculate charge transfer upon time. Total charge transfer divided by total time. Next point, if you want to calculate the charge transfer from this equation, it will become integral of I dt. So integration of current with respect to time will give you the charge transfer. We know that integration basically means area under the curve. So area under the current time curve, area under current time curve will give you what? Charge transfer. Okay. Second thing, we can say that slope of charge versus time graph, slope of charge versus time graph will give the value of current. Okay, simple mathematical problems can be there on this one. Okay, so for example, current versus time graph is given. For A and for B. Okay, not current but charge versus time. Take it charge versus time graph. So charge versus time graph is given for A and B. AB. So which current is more? So current of in first case is more than current in B case, because here slope of A is more than slope of B. So slope of A more than slope of B. So current in A more than current in B. Okay. Sometime to confuse you, the angle they will give you from the charge axis. They can give you the angle from the charge axis. So while calculating the slope, angle is theta, so slope will be how much? Tan theta. So you have to keep in mind this theta is from which axis? From time axis. Now wherever y axis, x axis, wherever they can make the time. So angle you have to calculate from the time axis. Okay. Let's see this question. Current is given as 0.02 T plus 0.01 ampere. This is the current. So the charge that will flow through the wire from t equals to 1 to 2 seconds. Charge from t equals to 1 to t equals to 2 seconds. What charge will flow between this time interval? Okay, so we have charge formula. Charge flow will be given by integral of I dt. Simple. Now integration of current. Current is given as 0.02 T plus 0.01 into dt. Integration limit will be from 1 second to 2 second. Okay. So from here we will get the 0.02 T square by 2 plus 0.01 into T 1 to 2. So it will become 0.01 into 2 square is 4 plus 0.01 into 2 minus 0.01 into 1 square plus 0.01 into 1. Okay, so 0.01, 4 minus 1, 3 times, so 3 times 0.01, then plus we have 2 times 0.01, and here minus 1 time, so 1 time 0.01, so 0.03, 0.04, 0.03, 0.01, so it will become 0.04 coulomb of charge will go. Okay, 0.04. Okay, next question. Okay, next concept you can remember as a concept questions have been asked. Resistivity versus temperature graph. So resistivity versus temperature graph. Okay, so resistivity rho equals to rho naught 1 plus alpha delta T. This is the equation. Okay, so if you increase the temperature, resistivity will also increase. This is for metals. Okay, so for metals with resistivity, temperature will also, with temperature resistivity will also increase. So if you talk about resistivity, it would look like something like this for metals, if especially for copper, aluminum, like that. Okay, NCERT have mentioned this graph, so important. Second one, if you talk about resistivity versus temperature for alloy, so you remember this graph. This graph is for a particular alloy called nichrome. Okay, this is for nichrome. Next case, if you talk about semiconductor, for semiconductor, the resistivity formula is how much? M upon N E square tau. So when you increase the temperature, relaxation time decreases, but N increases. So N and tau together it increases. So resistivity overall will decrease. So for semiconductor, when you increase the temperature, resistivity decreases. So these are the three important graphs of resistivity that you have to remember. Okay. Next, current is given as I naught plus beta t. So I equals to I naught plus beta t. I naught value 20 ampere, beta value 3 ampere per second. Amount of electric charge that flows through in 20 second. So time is given 20 second. How much charge will flow? Okay, again simple question based on the definition only. So charge is given as integral of I dt. So I naught 20 plus 3t into dt. So I will integrate it 20t plus 3t square by 2 from what value 0 to 20. Okay, now so it will become 20 into time 20 plus 3 into 20 square 400 by 2. While putting 0 it will become 0. So I'll get 400 1 plus 3 by 2 5 by 2 200 into 5 1000 coulomb. So this will be our answer, 1000 coulomb. Few concepts before that we can see. There is something called drift velocity. So drift velocity formula is given as E by m into tau. Okay, this formula. Then if I talk about mobility, so mobility is drift velocity per unit electric field. Mobility will be drift velocity per unit electric field. Okay, now if I talk about current relation, so current relation is I equals to NEAV D. Okay, current per unit area current per unit area is current density, so it will become NE into drift velocity. Okay, next, so J will also be equal to sigma into E. Sigma here is conductivity. Okay, sigma equals to 1 by rho, and rho we already have m upon Ne square tau. So this much of things you have to remember. Okay, next concept, suppose this is a conductor with varying radius. Okay, so diameter of the conductor is continuously increasing, point number 1 at point number 2. So which of the following will be equal and what are the parameters that will increase or decrease? So first parameter here, current. So current at 1 will be equal to current at 2, because once the current has left the battery, it has to enter from other side to the battery, so current cannot change. Now if current is equal, so if I talk about current density, so current per unit area is current density. Now see, area at 1 is less, so current density at 1 will be more than current density at 2. Next concept, we have J equals to sigma into E. Sigma does not depend on shape size. Okay, so here E1 will be equal to E1 greater than E2. Okay, now if you talk about drift velocity, so drift velocity formula is E capital E by m into tau. So capital E electric field more, so drift velocity will be more. So drift velocity 1 will be more than drift velocity second. Okay, if I talk about drift velocity per unit electric field, that is mobility. So mobility is E tau by m. So mobility will remain same, mu1 equals to mu2. Okay, multiple times question have been asked on JEE and Neet, so you can easily remember this concept. Okay, next, if I talk about Ohm's law, so Ohm's law will get V equals to IR. So resistance will be equal to V by I. So here resistance formula is given as V by I, but R here it does not depend on voltage and current. Resistance is something that does not depend on external factor of voltage and current. So on what factor it depends? It depends on length, it depends on area, it depends on temperature, it depends on nature of material. So on 4 parameters it depends. Okay, so resistance formula will come out to be rho L by A. important point, what is length and what is area. So suppose this is any cross section that we are talking about, current is going in this direction. So perpendicular to that direction, we will get cross section area, and along the direction you will get length. So along the direction will be, along the current direction will be length, and perpendicular to the current direction will be area. Okay, based on this one, we have one question. So suppose we have a conductor like this. Okay, suppose we connect this end and this end, we are connecting them with battery. So they will ask you what is the resistance across this end. So you can take this one as A, this as B, and this inside going is C, inside width is C. Now this one is B. When we are talking about across A and B point, so see, in this direction current will go. Okay, so perpendicular to that will be our cross section area. So R will be equals to rho. Length will be how much? Along the direction. So along the direction we are going A, and perpendicular to the that direction B into C will be our area. R equals to rho A upon BC. Okay. Next concept. So if the resistor is given, if the wire is given something like this, radius at this end is A, radius at this end is B, and this length is L. So directly you remember this case for Neet exam, J exam, very important. So here resistance will become a rho L by pi A B. L is this length. So rho L by pi A B. See, if this area is uniform, radius will be R. So area will become pi R square. But here radius is not uniform, it is linearly increasing from A to B. So how much area you will take? Pi AB will be our area. Okay. Next, suppose we have spheres like this. Sphere A, sphere B, and this material, this medium 8P, this medium is filled with material of resistivity rho. So if you connect A and B across A and B, across A and B, what will be across A and B? What will be the resistance? Okay. So see here, from A to B you are moving. So you will go at distance from the center, you will go at distance x. Okay, along this direction you are moving. So you will take an element of how much width? Dx width. Okay, so at x distance you have taken an element of dx width. So this will be our element, somewhat like this. Okay, so from x distance you are going, and in this direction it is dx. So let's write down resistance of this element. So rho. Okay, length. See, in this from A to B you are going, A to B. So this one will be the length, dx will be the length, and this one will be your area, and area will become how much? 4 pi x square, because of spherical in nature. So resistance will be integral of rho dx upon 4 pi x square. X will vary from A to B. Okay, so after integrating you will get rho upon 4 pi x square minus 1 by x will become, so 1 by A minus 1 by B. This will be our answer. Okay. It's a, by the way, it's a previous year question of J mains itself. Okay. So let's see the next question. Based on the same approach, they can give you two cylinders like this. Inner radius A, outer radius B. Okay. Inner radius A, outer radius of the cylinder B. Length of the cylinder how much? L. So if you connect between inner and outer surface, what will be the resistance between inner and outer surface? So again, you will go at x distance, you will take an cylindrical element like this. Okay. So if you define its resistance, so it will become rho dx upon area will be how much? 2 pi x L. This will x is the radius, so circumference will be 2 pi x multiplied by length. Circumference 2 pi x multiplied by length, that will be its lateral surface area. So resistance will be how much? Integration of this term, rho dx upon 2 pi lx, x varies from a to b, so it will come out to be rho upon 2 pi l ln of b by a. This will be our answer. So these are 3 to 4 cases for resistance that you can directly remember. Okay, important for J and J, important from J and NEET exam. Okay. Okay. Next point about resistance. So stretching of the wire. Stretching of wire. So R is given as rho L by A. Area into length will be volume, that will be constant while stretching. When you stretch the rod, its volume does not go anywhere, so it will remain constant. So area can be written as volume by length. So when you put it, resistance will come to P proportional to L square. Okay. Now see, two type of questions can be asked on this one. A small change, small percent or large percent. Okay. So for example, length increased by 2% or 3% or 4%. Up to 5% we can apply it, so small value. So here we can say that which method will apply? Will apply error method. Which method will apply? Error method. Okay. So percentage change in resistance will be equal to, what is the coefficient? 2 multiplied by percentage change in length. Percentage change in resistance will be 2 times percentage change in length. So when length increase by 2%, resistance will increase by 4%, 3% it will be 6%, 4% it will be 8%. For large percent means more than 10%, we have to use what method? We have to use factor method. Okay, let's see one example. Length increased by 100%. So L is there, final will become how much? 2L. So what is the factor here? 2. R is proportional to what? L square. R is proportional to L square. So 2 is the factor of L. So R will be increased by how much factor? 4. 2 square will be 4. R will increase by what factor? 4 factor. Now percentage formula is factor minus 1 into 100. So factor minus 1 into 100 will become 300%. Okay. Factor minus 1 into 100. This is our percent formula. Just one more question. Length increased by 50%. So what will happen to resistance? length increased by 50%, so what will happen? Okay, so length will become how much? 3L by 2, 50%. What is the factor? 3 by 2. So resistance will increase by what factor? 9 by 4. Percentage formula is factor minus 1 into 100. So 9 by 4 minus 1 into 100. So how much? 125%. This is our answer. Okay. Similarly, if length increased by 10%, length increased by 10%. So if you see the error method, resistance should increase by how much? Increased by 20%. But this is the wrong option. They will, right option will come out to be how much? 21%. 21%, because which method will apply here? Will apply factor method. So while applying factor method, you will get how much? 21%. Okay, keep it in mind. This question is true for G is proportional to R square, also R power minus 2 also. This is also Neet PYQ. Radius of earth shrink by 2%. Radius of earth shrink by 2%. So here G will increase by how much? Radius decrease, G increase by 4%. But if radius shrinks by increases by 10%, then G will decrease by how much? 21%, not 20%. Okay. Each of the resistance is R. So what is the equivalent between A and B? Equivalent resistance between A and B, R equivalent. Okay. Now, so see this upper part, remove this lower part. If you remove this lower part, you will find out this upper part is nothing but a Wheatstone bridge. Upper part is making what? A Wheatstone bridge. And in Wheatstone bridge, we know that when all of the resistors are equal, when all of the resistors are equal in Wheatstone bridge, okay, in Wheatstone bridge, when all of the resistors are equal, then equivalent will become R itself. Okay, remember this point. All of the resistors are equal in a Wheatstone bridge, it will become a balanced Wheatstone bridge, and R equivalent will come out to be R itself. Okay, so upper branch has how much? R. Lower branch also has how much? R. So R equivalent total will be how much? R by 2. R and R in parallel, product by sum, R by 2. Okay. Okay, next. Okay, next arrangement we have here. Okay, point A, B. So here we have 2R, here we have 9R, here we have 3R, above one is R, below one is 6R. Okay, it's a linear form. In a line, multiple resistors are given with different branches. Okay, so if you look at it from this perspective, you may find it a little bit difficult to solve, but just let me break it down for you. So if you take upper branch, one branch from A, R resistance. Okay, now so similarly another branch from A has how much resistance? 2R. Okay, see this point is going at A dash, this point will go at B dash. So between A dash and B dash we have 9R. So between these two branches we have how much? This was actually 2R. In this one we have 9R. Okay. Now from B dash we have 3R. So from B dash we have 3R, and from this A dash we have 6R. So from this point this is A dash, this is B dash. We have how much? 6R. Okay. Now what system it is making? It is called Wheatstone bridge. Let's check whether it is balanced or not balanced. So this one and this one product will be 6R square. This one and this one product will be 6R square. Opposite products are what? Equal. So it is balanced Wheatstone bridge. So in balanced Wheatstone bridge, what happens? In balanced Wheatstone bridge, the middle one is discarded. Remove it from the circuit. So upper branch will have how much? 3R and R, 4R. Lower branch we have how much? 8R. So upper branch will have 4R, lower branch will have 8R. So R equivalent will become how much? Product by sum, 32R by 12. Okay, 4, 8 by 3R. And this one will be our answer of this question. Okay, moving forward to the next question. Okay, let's see next. So we have a wire of resistance R. Okay, a wire of resistance R. We are bending it in this form, in a square. We are bending it in a square. A, B, C, D. Okay, so there is E is the midpoint of DC. So they are asking what is the value of R equivalent between E and C. So between E and C, what is the value of R equivalent? Okay, let's see. Now see, each of the side total one is R. So each of the side will be of 1/4 of the length. So each of the side will have resistance how much? R by 4, R by 4, R by 4. Now CE part will have R by 2, ED part will have R by 2, half of that, R by 8, R by 8. Okay, now see C to E. So C to E, one branch we have this complete one, and other C to E we have one branch and two branch. So C to E, if I draw the point, one branch we have how much? R by 8 resistance. Okay, let's see other branch. From C to E, R by 4, R by 4, R by 4. How much we have? 3R by 4. So from C to E we have two branches, one directly whose resistance is R by 8, other one in this direction whose resistance is 4R by 3. So what will be the value of R equivalent? Oh sorry, 4R by 3 plus R by 8. 4R by 3 plus R by 8 will be there. Okay, so when you do 8, 6 plus 1, 7R by 8. So R equivalent will become 7 product by sum, that's what we have to 7 by 8 into 1 by 8 R upon 1. Adding both of them you will get 1. So you will get how much? 7 by 64 R. R equivalent will be how much? 7 by 64 R. Okay.